Okay, so I do want to do one more review example of a titration problem. So here's another example. It says Mr. Marquis has 100 milliliters of a 3.5 molar solution of sulfuric acid. How many milliliters of the 1.5 molar concentration of AlOH3 would be needed to neutralize this mess? All right, here's the idea. Molarity is moles per liter. We're going to solve for the moles of that one because we're going to be given the amount and the concentration of one of the things, the acid or the base. Then we're going to go from moles of one to moles of the other. And then I'm going to use my molarity formula a second time. So we bookend the molarity formulas around the moles. Okay? And because we have moles, we need the coefficients of the balanced equation. I might as well write the balanced equation first. All right, so that's kind of where we're at. Titration problem. And again, we've done a few of these in our labs, or we will very shortly. So let's first write the balanced equation. I've got H2SO4 and AlOH3. These are written like this because H is a plus, SO4 is a 2 minus, Al is a 3 plus, OH is a minus. That's why you need 2 H's with that OH, the SO4, and why you need 3 OH's with the Al. Okay, this is a double replacement reaction. You're going to get the H with the OH, which is your water, always going to happen, and then the Al with the SO4 to form aluminum sulfate. So Al2, SO4, 3. All right. So there's your balanced equation, or there's your equation. Now let's balance it. Tips to balancing. 1 Al, 2 Als. I better put a 2 there. I guess I would do my S's next. 1 S here, 3 S's here, so I better put a 3 there. I guess I'm going to do my H's next. I've got 6. And I've got 3 times 2. I've got 6 more, so that's 12. So I need a 6 here. And let's just check my O's. I bet they're okay. 12. 3 times 2 is 6. That's 18 O's. And here I got 6 and 12. I got 18. So I'm all balanced up. All right, beautiful. Molarity is moles per liter. I'm given the concentration and the amount of my acid, so I can solve for moles. It's going to be molarity times liters. So my moles is equal to 3.5 molar times 0.1 liters. I multiply those, I get 0.35 moles, and now I'm going to write what it is, the H2SO4, right? The H2SO4. Okay, so now I'm going to moles. Might as well do it right down here on the bottom. X line, moles H2SO4, moles AlOH3, my sulfuric acid to my aluminum hydroxide. I get that from my coefficients of the balanced equation, 2 and 3 respectively, and I multiply by 2, divide by 3. I did this one over here, and I get 0.23. So 0.23 moles of AlOH3. Now, notice that it says, let me grab one more color here. How about green? It says, how many milliliters of this concentration? So I'm going to be using my molarity. I don't like this green. Let me get purple. Molarity is moles per liter. Notice now I have my moles and I have my molarity. What I don't have is my liters. I like to rewrite. Let's get that liters out of the denominator. So I get liters times molarity equals moles. But I want to divide by my molarity to get liters. So liters is equal to moles over molarity. My moles is 0.23 moles. My molarity is 1.5 molar. When I divide those two, I get 0.156. That's liters, but I want milliliters. So 156 milliliters of my aluminum hydroxide is what I would need to put with that 100 milliliters of that concentration of my sulfuric acid. And so that's another titration question.